So our next speaker is Ben Escobedo from Shure. Ben's manager market development at Shure Incorporated with 20 years experience in the pro audio industry. He's held diverse roles in project management and sales. Collaborates closely with leading clients in the house of worship, broadcast, theater, and live sound sectors, specializing in RF and wireless microphone technology. He's a frequent conference attendee, provides training sessions, and cultivates relationships among dealers, end users, and manufacturers. So welcome, Ben.
Thank you. Thank you very much. Thanks everybody for coming. My name is Ben, and we're talking a little bit about the Super Bowl and some frequency coordination and wireless microphones in general. Mostly, for the most part, sub-gigahertz is kind of where our world is, and a peek inside how that all works. Let's keep it open. If you have any questions, please ask. Keep it conversational. If something you want to dive down into, we can do that. But I figured today we talk a little bit about, overall what's going on at the Super Bowl, or the DTV landscape of where we operate in the majority of wireless microphones, the spectrum challenges that we face at large events like this. In my opinion, in the US, this is probably the premier, one of the most, if not the most complicated event to manage for RF and wireless microphones and make sure everybody's happy, everything works well. You got 600+ million people watching, so it's quite a big deal. As it's often said in the industry, it could be your best gig or your last gig. There are plenty of people that pass up the opportunity to work on Super Bowl because if something goes wrong, then everybody's going to know about it, and you'll be on that do not call list. Talk a little bit about wireless mic requirements, which are unique as far as wireless transmission goes. There's some requirements for wireless microphones that are unlike any other industry, whether it's cellular or Wi-Fi or whatever the case may be. There's some challenges that need to be solved, and we have to do it in a very small amount of bandwidth. And then we'll talk a little bit about the RF-focused companies that make this all happen, and kind of the hierarchy of the structure of how it works, and who's involved, who actually has the gear, who's renting the gear, who's operating the gear. The ref and halftime mics, also known as ref and entertainment mics, are a separate portion of the coordination every year. And then we'll talk about zoning and war games. Essentially, how do we test the system when it's all up and running and making sure it's bulletproof and it's going to work well. And then any other questions that you might have as we go along. So a little bit about me. Yeah, I'm market development, and my wife asked, how do I explain what do you do? I'm kind of like a sales guy without the quota. I want you to buy our product, but if you don't, I'm not trying to chase a number at the end of the month. So I have good relationships with broadcasters and theater, location sound, live sound, touring, all the way from A-list artists down to location sound users that may be recording their next commercial or something. And what they all have in common is wireless microphones, and they're passionate about it. So sometimes we do really highly technical challenges of things that have never been done before. I've got this idea and I want to use wireless microphones on it. How do I accomplish it? Also just high-end troubleshooting, high-end technical training, just RF best practices as it comes to wireless microphones. So for me, I love the variety. It's not the same thing day in, day out. One day I could be backstage with whatever artist it is, or at SNL, or under the stage at another thing, you name it. I get to be a fly on the wall for a lot of this type of activities, and it's always something different and new. And I add value when I can, and most of the time when I'm there, I'm a fly on the wall, and I get out of the way and let the people do the work and pull the cable and whatever they're doing. So that's a little bit about what I do in this journey of professional audio is really what I focus on. So as far as spectrum is concerned, the majority of wireless microphones for the professional use case are in the UHF band. After the auctions we've had, 470 to 608 contiguous is the lion's share of the microphones, but we do offer microphones in different ranges for different use cases. We'll talk a little bit about the pros and cons of that, but the VHF range, we do offer some microphones in VHF, typically 174 to 216. These microphones are great because it's a different range and maybe not as crowded. However, obviously the wavelength is going to be larger at lower frequency. So the antennas and resulting antenna size for the VHF are quite big, and that is obviously not great on camera. So VHF microphones do have somewhat of a place in professional applications, but not as common as UHF, if you will. The UHF spectrum that we work in, 470 to 608, and then the gap for the radio astronomy band, and then with that little guard band, what we use about 614 to 616. That's probably the #1 area where wireless microphones for professional use are located. And it's a great combination of long battery life, good wave propagation, manageable antenna length. All of those type of kind of pros for the UHF is really the sweet spot. Our biggest enemy is DTV, and usually DTV is something that's it's not going to be sporadic for the most part. It'll be on all the time, so you'll know if you have a problem pretty quickly. But we use the spaces in between active DTV stations or where DTV is not well received. That can vary depending on the venue and outside shielding and such, but this really is it's a great balance in the frequency spectrum. Of course, years ago, after the last auction, we had other higher ranges up in the 700 all the way up to 806, but this is today what we're working with. We do have some mics in the ISM and STL bands. So the ISM band, in the lower 900 megahertz, we have a system called ULXD, which operates in there. And we do also offer some microphones in the STL range of 941 through 960. This is an attractive range for Part 74 license holders to use because it's something that you can't really walk into your local guitar shop and get it off the shelf. It's going to be a custom thing. It's not available to the general public for the most part. So there's some exclusivity there in those bands to kind of keep you away from what's going on in the UHF range. The same thing would apply for use case in the duplex gap in the mid 600s. A lot of times we might put artist microphones in that range because, again, it's less likely that somebody would fire up a microphone that they bought at their local retailer on that frequency. And then, moving up in the spectrum, we do have some microphones that operate on the decked band, 1920 and 1930 in the US. These aren't typically live performance microphones because of latency requirements. Latency and low latency is a very big deal for professional artists and musicians, especially if you're using in-ear monitors, because any perceived latency back from the system in your ears, you hear it instantaneously when you sing, and your kind of jawbone goes right up to the hammer, anvil, and stirrup in your ear. And if you get that back over about maybe 6 milliseconds or so, it starts to get a little weird. People are like, man, I hear some weird stuff going on, and they're experiencing the comb filtering effects of that. It's not so much an issue when you have like wedges on stage, but man, when you have something directly in your ear and then you're getting it directly conducted through your bone and your jawline, that can really make artists have some issues. So most of the decked microphones that we offer in the 1.9 are going to be your conference microphones and latencies of 14 to 17 milliseconds, which is totally acceptable for conference applications, for presentation applications, and so forth, but really not something you'd find a lot of for the professional realm for wireless mics. On the flip side, decked is very common for high-end comm systems or intercom systems that do operate in that range, because latency, again, isn't that much of a concern. They're more concerned about the reliability and the message getting through. And then Wi-Fi DFS, we offer a whole bunch of mics. Of course, as a manufacturer, it's really nice to have one range that we can manufacture and have it worldwide, right? And it needs a lot of regulatory compliance across the globe. We don't have to worry about different frequency ranges. The customer doesn't have to worry about what frequencies they select. You turn it on and it just works, right? Well, yes and no. As you know, Wi-Fi is very congested, especially 2.4. And on a good day, if you have a great RF environment, maybe you'll get 8 to 12 or 8 to 14 wireless microphones, and they work well. But on a bad day, you could get 0, and it's nothing you could do about it. When you turn it on, the system scans your frequencies, and if it doesn't find what it's looking for, you've got nothing. been to many installations in like house of worship or churches, and they'll have a bunch of 2.4 systems and everything's working great, and then they'll put in a Nest thermostat or something, and then, what happened to my wireless mics? What's going on? So that's a consideration. So we don't see too much of Wi-Fi as far as professional wireless microphones. And then we do offer, some in the 5 gig and the DFS channels, including the system that's on the table in front of all you right now, MXCW. That's a tri-band system that kind of uses 2.4 or 5 gig in DFS. Again, latency and congestion is not really a concern because it's a conferencing application, but we do take advantage of that spectrum. But we'll be coming back mostly UHF, mid 470 to 608 is the lion's share of it, and then mid 600s and the STL band 941 through 960 is kind of where we're at. For those unfamiliar, we refer to the spaces in between unused TV stations as white spaces, and this is where wireless microphones live. Anyone from somebody at the bar band down the street to NBC 30 Rock, they are taking advantage of unused television stations. If 15 and 17 are occupied, 16 with the lowest noise floor is where we're going to put our microphones. The rules have adopted with the last auction, where there is allowed co-channel operation. If there's a TV channel that's active by the documents, but you're inside and it's attenuated because of the building, you can use it. Obviously, the higher the noise floor, even if it does work, the less range you're going to have because your carrier to noise ratio is going to be upside down. But this is the game of what we're looking at as far as spectrum is concerned. Most of the time it's DTV. I mean, they're many multitude times stronger than wireless microphones. It's not like you're going to take out a DTV station by operating a microphone on it. It's going to be the opposite. They're going to run you right over. And then another thing we struggle with quite a bit is the T-band, or the lower, channels 14, 15, 16. In a lot of major metro areas, the T-band is public safety. And unlike DTV, T-band is sporadic. You do a scan with your system and you set it up and everything's cool. And then all of a sudden there's an emergency or fire or whatever goes by and somebody keys up their T-band radio, they can knock you out. Of course, it's illegal to be operating in that range anyway, but unsuspecting users could have a bad experience with that in the T-band market. So even if the channel seems to be free and you don't see anything there, it's sporadic. And that is a challenge, especially in all the major metro areas, Chicago, New York, DC, LA, and others. So that's kind of our homes where we're looking for wireless mics. And it's getting harder. I mean, obviously we lost a lot of spectrum on the last couple of auctions. And we're looking at here at Super Bowl, the vacant DTV stations that are below 608 megahertz. Of course, the more, the better. And just to kind of quantify this for you, most state-of-the-art low latency wireless microphones, if you have a 6 megahertz TV station available, you can get around 17 microphones in that band. We have some other modulation techniques which give you a little bit higher latency and a little less perceived audio quality. You can max it out at about 47 channels in that band, which may be appropriate for your broadcaster, your talking head, but really not used for audio for the halftime or the musical performance because of the latency requirements. But as you can see, depending on the city, it can be quite challenging to get the 400 frequencies that you need for Super Bowl in one of these cities, depending on how many open TV stations that are there. So of course, we're using things to our advantage, like building shielding, STAs for alternative frequency bands when appropriate, and just careful planning and zoning to make sure everybody has a good experience. Yes, there is a hierarchy of importance, right? You've got your ref microphones and your entertainment for the halftime show that are way up there. You've got your rights holders and your sponsors for the Super Bowl that year. Maybe it's a Fox year one year, maybe it's CBS year. Those are going to be your highest priority type of coordinations. You're going to give them the best frequencies. You're going to take care of them the most. And then in addition to everything going on, you may have a lot of ENG or electronic news gathering, people that are coming in, reporters, and doing their own little spots and such. And maybe you get that frequency, maybe you don't. But everything at the compound where Super Bowl is being held has to be identified and recorded, and what frequency you're using, what power you're using. You get a little flag that says NFL on it, coordinated frequency, and you have to be on that frequency. And everybody's got to stay in their lane and use the frequencies as assigned by the frequency coordination team. It's paramount for everything working correctly and it going off without a hitch. What we're looking at here is a Win Radio. One of our colleagues, Steve Caldwell, was at the portion of the Super Bowl where it's essentially focused on the ref mics and the entertainment. It's its own little compound. They're right there. They have racks of gear. They've got their own antenna infrastructure, and they are responsible for just those things. Just halftime show, which is super important, and then of course the ref microphones, which are super important as well. He's got like this widescreen monitor with Win Radio set up and looking at the spectrum, and you can see, just the number of microphones and where they're at. Again, this doesn't include what's going on at the Fox News compound or the Fox Sports compound. This is just halftime and ref mics and what they're using in this portion of it. And his job is to ensure things are going well, identify any rogue interference that's happening. If there's any problems, have backup frequencies at the ready, and monitor the performance of the microphones using software. One of the software has been used as a Shure Wireless Workbench, which is a command and control software that gives you metrics about, RSSI and RF performance, and what we call Q, which is a combination of carrier noise ratio and bit error rate of how the microphone is performing. You get a little early warning before there's a complete dropout. So this is his whole, day in, day out. And, we're looking at coordination 6 months in advance before, because not only, you kind of know the city that you're going to and what the challenges look like from a DTV landscape, but what equipment do I bring? Not every equipment is band agile where I can just tune it to whatever frequency I want. I got to bring specific gear for specific use cases. So, part of that equation is sourcing the gear and making sure it's available. And then, you're setting up a week ahead of time or more. The infrastructure and the distributed antenna system is going to be there before that. And you're going to get in there and hook up all your stuff, make it all work. And then you're faced with a bunch of rehearsals. There's a ton of halftime show rehearsals. You're going to do the halftime over and over until they get it right. And they're going to time everybody pushing things on the field and how long it takes them exactly to the second to get off. And a whole army of people doing that until they can get it right down to the second of exactly what they need and how it's going to be. As soon as the halftime starts and the commercial kicks in, they're all busy pushing all the set and everything and making sure the wireless microphones are good. And being a fly on the wall at these events, you get to see the halftime show like a dozen times over and over before it's public for that year, which is kind of cool, but a little monotonous after you see it a few times, of course. But in addition to the bands that we are using, like, the contiguous I mentioned, up to 608, some of the duplex gap, and also the STL band 941 through 960, there are a few STAs at this year's Super Bowl, but only 2 of them were less than 1 gig for mics or IFB or IEM use. For those unfamiliar, IFB, interruptible fullback, is like the little bud in the newscaster's ear where the producer can talk to them and tell them, hey, so-and-so is going to come on here. We're going to commercial in 30 seconds, or if it's your tie, whatever, private conversation link. But at this Super Bowl, there was only 2 for the mics or the audio portion. There were additional STAs for wireless video cameras and links of that nature. But land mobile radio and T-band STAs and some other channels 14 and 16, which would be used for something else. But sometimes there's more STAs depending on the severity of the RF environment, which is pretty neat. But wireless microphones, as I mentioned earlier, are like a unique thing where we have to do all of the things. Everybody wants everything, right? They want low latency, they want great audio quality, they want awesome battery life, they want reliability. It's like that big engineer's triangle by the web. And of course, if you want, more battery life, the pack's going to get bigger. If you want more transmission range, you're probably going to need more output power, which affects your battery life. Like that whole game. And with this type of application, we don't have the luxury of asking for the data back again. You can't just say, hey, give me that packet, or press F5 on your browser to get it. It's got to be there the first time and work right. Yes, we do have some error correction and such, but it can only make it up for a short amount of time. If we can make up audio for a longer amount of time, we wouldn't need performers. So there is that. But the majority of wireless microphones, as far as the microphone to the receiver, are about 1.9 milliseconds latency. And that's fine, but you also have the latency of the audio processing in the console, any plugins, and then also the round trip back if you're using in-ear monitors to hear yourself. And then you add that latency up, and you're hoping to keep that under 5 milliseconds, 6 milliseconds is the magic number if you're using in-ear monitors. So we're doing all of this in whatever free space is left in 200 kilohertz. 200 kilohertz is what we've been able to use for years until recently. Recently, regulatory constructs have come out where we can use larger blocks of that with what we call WMAS, or wireless multi-channel audio systems. But that is just a brand new technology. There's only, well, one or two systems on the market that are shipping right now that take advantage of it. And WMAS presents its own challenges. We can put more channels in a block and such, but if the questions arise of what the output power of that block is, and what happens when you get interference on that block. So it is an exciting thing to increase the density of channels on air given spectrum, but there are other considerations to take in play. At this moment in time, right now, the majority of wireless microphones are digital narrowband, 200 kilohertz. But there's quite a bit of analog in-ear monitoring still out there, 200 kilohertz analog with low latency. So we're not completely in a digital world yet. There are some considerations there, but I'm confident we will be there. Maybe 5-10 years from now, analog wireless microphones might be a thing of the past, but people have gear, it lasts a long time, it works. Why am I going to buy a new one? It's legal to use. So all of that type of stuff. And it's we've done really cool things with the technology and our modulation schemes and our codecs to make this all work and be reliable and sound great, have great battery life and great command and control. It's quite a feat to do all this inside of 200 kilohertz in free open air. It's crazy. So the Axiom Digital product is Shure's flagship wireless. We saw about 85% of Super Bowl wireless microphones on Axiom Digital. It's not really a surprise. It's kind of the industry standard for most professional applications. I'd say about 95% of New York City broadcast is Axiom Digital. It's a tried and true and tested system. We released Axiom Digital in 2017, which was great timing right after the last incentive auction. And a lot of broadcasters and other users had to buy new gear, and they were looking at what system should I go with? And this was at the right place at the right time with the right feature set and price to performance ratio. If you look at many of your favorite television shows or anything with a wireless microphone, it's likely something like this. Axiom Digital is everywhere. As mentioned, most users use it in standard mode, which is the normal mode, 17 channels per 6 meg. And of course, because the industry coins it as intermodulation free, it doesn't really create intermods with the transmitters. You can pack another 17 channels right next to it if you want. It's not because it's digital, it's because that the amplifiers inside are so linear that you don't have a problem creating harmonics. 1.9 or 2.9 milliseconds, depending on which mode you're doing. And then we have a feature called quadversity if you'd like to deploy it, which is essentially a doubling up of your radios. So instead of using 2 antennas for diversity, or what our marketing team calls true digital diversity, you can use it in quadversity mode where you have 4 RF lineups and 4 radios all listening to an antenna. And this is something that has been deployed at Super Bowl last 4 or 5 years now. For reliability, when it matters, you're going to make sure that you have redundancy built into the system. Some of the focus companies at Super Bowl, I mean, you have got your NFL organization, you've got the rights holder for that year, the Fox, the CBS, whoever it is, and then they have companies under them who they contract to bring their RF expertise and their antenna systems and their gear and operate that gear on field. So a lot of it this year was divided where CP Communications handling a lot of the communications around the arena, a lot of the intercom systems, help filing STAs with the FCC for access to ranges that normally wouldn't be used. And then the JetWave and Digital Black are companies that are, very familiar with RF over fiber. They were hired by Fox to make the Fox compound work, not just at the Super Bowl, but having a fiber link from the Super Bowl to Bourbon Street where they had a remote desk and there was wireless microphones there. So they tied the two separate areas in together over fiber as one big RF system, and they could capture mics from anywhere. And that's what they're mainly focused on. And then the Clear Global, which is kind of the largest touring company in the United States or in the world, and ATK. ATK is in California, is part of the Clear Global brand. They do a lot of the award shows, the Grammys and things of that nature. They work with professional wireless systems and strictly focused on the entertainment, the halftime show, as well as the ref mics. That's what they do. That's what they're responsible for. That big scan we saw with Win Radio there, that was just that portion of the show. And maybe it's only 5-10 minutes for the halftime show. It's extremely important. Everybody's watching it and it's live. You can't have any problems or any dropouts. So a lot of these companies, especially on the ATK side, professional wireless, some of these people have been doing it for 20 plus years. It's like a road family. They don't see each other but once a year at wherever the Super Bowl is, and everybody knows what job they have to do. And they pick right up where they left off, and it's a well-oiled machine. So doing it with that kind of level of experience and knowing what to expect, granted with the RF and spectrum challenges, they can solve them as a family, which is really great. So it's funny because these are competitors with each other in many cases. Before the merger, Clear and ATK were competitors, but now they're the same brand. But CP and JetWave are competitors. They have a little bit different area of expertise. JetWave is highly focused on RF over fiber and complex antenna distribution for broadcasters, especially in New York and elsewhere. And CP is also heavily into RF, but maybe on a different side, more for the live sports applications for broadcast. Doing really cool stuff like putting wireless microphones in golf cups so you can hear the dink of the ball into the cup, and hiding mics for the World Series under home plate and stuff like that. That's what they do. They do all that kind of specialized, like how are they capturing that audio? That's a lot of what they do. But everybody works together to achieve the dream result. Here's a quick peek at Steve's area there with a big monitor and the Win Radio setup, and just one of the racks. Again, this is the rack looking, or portion of the rack for the halftime entertainment and for the ref mics. And all this gear here is explicitly for that. The entertainment mixers, especially the monitor mixers and such, have big consoles that are located right here. And all of this is located under the stadium, like under the bleachers in the back kind of hallway area. They're not on the field, although this year you can see like about that much of the field through the corner if you needed to and run out there. But most of that personnel and equipment is under the stadium. And this is kind of makes it so that they have to run long antenna runs. And of course, RF doesn't like to run over cable that far. So a lot of this, would be on a RF over fiber distribution system for the refs and the halftime show. Pretty impressive stuff. A little bit about, the quadversity mode that they were deploying, especially for the ref mics. Usually we sell our Axiom digital receivers on a 4-channel box. The 4-channel box, there's 2 radios per channel. And in quadversity mode, you turn a 4-channel unit temporarily into a 2-channel unit. And what you're doing is you're taking channels 1 and 2 and the radios that would normally be assigned to them, and you're assigning that all to the same frequency. And the same thing on channel 3 and 4, you're pairing those together. So every antenna A, B, C, and D has kind of a home run to a radio of that particular channel. And the sum is greater than its parts. The reliability is over double doing that. You'd have to break all 4 antenna streams in some bad catastrophic way to have a dropout. And it's just going to aggregate the constellations and everything from each one of those antenna points for the best and ultimate range and reliability. Of course, you could use quadversity as they at the Super Bowl, where you have it on each corner of the field for great reliability. But you could also use it to extend your coverage by putting 2 antennas in one area and then 2 antennas maybe at a backstage area and such. Not to get too far off topic, but quadversity and deploying 4 antennas per zone is becoming pretty commonplace in like New York City broadcast. New York City broadcast, very dense RF environment, a lot of channels, over 400 at a 30 Rock alone, and they all have to work together all at the same time. So what we've been seeing is like deploying quadversity in the studios, but keeping the power down. So you can able to use less power, transmit power off the belt pack or the microphone, and then keep that one area super robust and contained. And then that allows you to multiplex or reuse frequencies down the hallway. So Jimmy Fallon doesn't interfere with what's going on in SNL or Seth Meyers or whatever in 6A. So, this is becoming not for everyone, and it's just an option. The penalty for using quadversity is that you take a 4-channel receiver and it temporarily becomes a 2-channel receiver, so you get half the channel count. But the robustness of it is unparalleled, and when it matters and it's absolutely important, Shure quadversity antenna deployment is really kind of second to none. We've been seeing a lot of it. So looking at a couple things here. The field, it's pretty standard that we would see this antenna set up on all 4 corners of the field. You got our UHF antennas there in quadversity for antennas A, B, C, and D. And then you might notice some other things there. You've got your 2.4 gigahertz, what we call ShowLink. So ShowLink is our back control for our wireless microphones that operates using the Zigbee chipset, but it's our own implementation, our own protocol on Zigbee designed for speed and reliability. That allows the operator to make remote changes on the fly if they needed to change anything on the pack, like frequency or gain or trim or lock it or whatever. They can do that remotely, which is great. And now with the latest iteration of ShowLink and our new digital ear system, they can get telemetry back from a receiver pack, which is the first time ever. Exciting, because operators can see battery life and things of that nature, which is great. So these are sprinkled around each area here. And again, this is just for the refs and the halftime show. There's a separate DAS for the Fox compound, if you will, so that whoever boomer can walk around and interview players and sit at the desk or roam just about anywhere they want and not have to worry about antenna coverage, and everything's seamless. So pretty interesting to see it at this high level of deployment, and what actual equipment, what they're using for this type of application. It's not uncommon. Helical antennas or circular polarized antennas are pretty common for range and reliability. No sense in picking up things behind you where it doesn't really matter. You can focus on what does matter, the refs first and foremost. And then the Fox Sports compound on the left was the desk this year, and that's of course where all the commentary you saw and everybody doing the play-by-play and all that. And it was kind of unique this year that the desk itself and the big banner up top was all on hydraulics, so they could like put it down almost to like about this high table level. And then, during commercial or whenever it was appropriate, they could, inflate it back up, and then it was great. When it was down, it was hidden under a tarp, and it was like it wasn't even there. Certain stadiums, some years they have like almost a semi-permanent structure built that doesn't move, but this year they did a collapsible thing, which is respectful for the fans that are right in front of it, so they can see through the desk, of course. And then, JetWave and our counterparts, our RF gurus, were working under the stadium for the Fox. And again, these people are focused solely on making the Fox thing work well. So we're talking about a whole bunch of handheld microphones, a lot of lavaliers, and a lot of IFB units. And they had a very complex RF over fiber setup for at least 5 different antenna zones in the facility itself. And then, of course, I was mentioning that link from the Super Bowl dome all the way to Berman Street, so they could have command and control and RF distribution out there as well. So pretty cool to see those type of 2 different entities that are kind of at the stadium operating in conjunction with each other, but on separate DAS, separate antenna systems, separate goals. But everybody's goal, of course, is to have no dropouts, no problems, 99% uptime, that whole thing. A little bit more about some of the equipment here. We talked about the RF over fiber, a lot of matrix for field locker rooms and such. The fiber connection to Bourbon Street, both mics and IFBs running on a fiber distro. And then again, this was one of the first years we did the HD mode, which is that mode that can do 47 channels of audio in 6 meg with 2.9 milliseconds of latency. It went flawlessly. And this is the mode that we're using in broadcast in New York to get the channel count with the amount of spectrum that's available. So we're really maximizing spectral efficiency and reliability and backing it all up with quadversity antenna deployment for utmost reliability. And then zoning, of course, when we're coordinating things, if they're outside of the transmission range of another user or another entity, we can multiplex and reuse the frequencies because we know they're far enough apart where they're not going to affect each other. So there was multiple zones here across the campus, including the purple carpet and radio, Telemundo, Fox Studio, Fox Game, Fox Deportes, NFL Films. There's a lot of entities running around and making it happen. And these are all different zones because maybe where they're operating is just going to be outside of the transmission range of something else. Especially if you're outside the perimeter, there's a separate kind of zoning and coordination from what's in the building due to building attenuation. And then war games. So war games is going to happen at a specified time before the event, after everything's dialed in. Everybody's got their frequency. You might have had a few rehearsals by then, might have practiced America the Beautiful and the anthem and made sure everything's going well. But essentially during war games for a few hours, everybody has to turn all of their microphones on and leave them on. And that is mandatory. Everything that's going to be in use during the game all has to be fired up in the worst case scenario and left on. And at this time, of course, you're looking for reliability. Is your stuff working? Is it going to be okay during the actual event when things are going to get crazy? Additionally, we have personnel looking for rogue RF carriers, somebody that fired something up that they weren't supposed to or forgot what frequency it was on or tried to sneak something in. And they'll be going around with their spectrum analyzers and directional antennas, playing a little game of find the interfering person and have a little conversation with them about, what happened and why is your stuff on? We told you only 100 milliwatts, why are you using 250? That sort of stuff. And this has been a staple of our coordination at the Super Bowl, just to ensure everything's going to work well and that you're really giving it the old test right before. And the worst case scenario, it's very likely that all these mics won't be on at the same time. The entertainment mics or halftime show are not going to be burning on during the first quarter of the game. That's not really a thing. But you're going to make sure that everything's going to work well and it's been tested thoroughly before you actually go to air live where there's no do-overs, right? And that's about it. For the record, I don't frequency coordinate the Super Bowl, but I'm friends with the people that do. I do some other frequency coordination for broadcasters and such, but this is probably one of the hardest gigs ever to actually coordinate and make sure everybody's happy. Not just a mathematical thing and making sure that you have the right spectrum and the right gear, but a lot of it is the relationship building. It's the ability to negotiate and talk to people and they explain their situation and come up with a resolution if you can, and be respectful of each other to make this all work together. Again, there's a hierarchy of importance, and I've seen it firsthand where somebody came in for a really big artist and out in the parking lot, and they had only one range of wireless, and it was not able to be used because they brought the wrong range or they didn't give their desires of what they needed before they showed up to the thing and just expected to turn it on and it works. That's not the case. A lot of planning and pre-planning goes into effect here to make sure that you have a really good situation. And then, of course, when you get there, there's going to be some things that aren't going to work out exactly as you thought, or a frequency might be dirty that you thought wasn't. And that's where it all comes into the communication and just, hey, what can we do about this? What range can I use? Can I get some other band gear somewhere else? Do you have any suggestions of how I can, make my A-list artist happy and do the tailgate in the parking lot and make sure that's all going to be good? But again, all this planning starts way ahead of time, at least 6 months or greater, where they're sending personnel to the site, exploring what's there, doing some scans, what's the antenna infrastructure, is there fiber there, and trying to put together a game plan to make it the best possible every February. So that is my 2 cents on Super Bowl or the world of coordination. If you have any questions, please let me know. Yes.
Go ahead, Rich.
Thank you. Great overview. The 902 to 928 band,
Yeah.
did you feature that? Do you happen to know what the extent of broadcast or other wireless mic activity is?
We were
in
just
that
talking
band
about this
today?
on the car ride over here, actually. 902 to 928 is not very prominent in wireless professional audio. We make a product that does operate in there, but I'd be hard pressed to say that like many touring artists, bands, or Broadway or broadcast is going to use that because mostly of the unpredictable nature of it. It's not the widest band available. And there's so many other devices that are operating in 902 to 928 that, for mission critical applications, it doesn't make a lot of sense. It's nice to have that option, but it's not something, let's put it this way, it's pretty rare to see one of those microphones out in the wild. It would most likely be in a conference situation or a hotel ballroom like we're in, or an educational facility. We make the ULXD microphone line in that frequency band. And then I believe Sennheiser makes a speech line wireless as well. Actually, that's a different frequency band. Yeah, that's few and far between is the correct answer. Not in everyday use. Yes.
Just out of curiosity, for the microphones themselves, what kind of vocoders and codecs do you use for the very low latency?
That is a great
Do
question.
you make your
That
own?
is a blend of 11 herbs and spices that's proprietary. Yes.
Your own vocoders?
We build our own because nothing off the shelf satisfies the
Understood.
requirements that what we need to do in 200 kilohertz. So there's nothing, off the shelf codec that's going to work for the latency and the reliability requirements and such.
Well, I'm really curious about what the alphabet is. So like, for regular vocoding, the alphabet's limited, but if you want to be able to like squeal and scream into the microphone and do funny things. And funny
Yeah, we're
noises,
talking 130 dB.
well,
So then-
also the kinds of sounds you might make, which people wouldn't use in ordinary speech, right? So
Oh, of course, yeah. Not just the range of speech, but where we're talking about symbols and things with high transient content, and like we're talking 20 to 20K. Of course, there's compromises, and it's not going to be ruler flat everywhere, but it's going to be very, very close and very good.
so it's not really a vocoder, it's something a little different. I mean,
Yeah, we have our own modem team, we have our own codec team. We actually make our own silicon. We have our own chips that are designed specifically for our wireless microphones. So we don't say it enough, but it's like having our own, M4 chip or whatever that we have that's designed. It's really good at codecs, it's really good at modems, and it's good at wireless microphones. And it allows us to do some really cool advanced things that you just can't get from Mouser or DigiKey.
So I think what I just heard is he can tell you the specific details, but then
I don't even know the specific detail. I get to hang out with those guys every now and then. I always learn something. The
how big a
challenges.
team is it? I mean, how many guys? I'm just curious.
Oh yeah, there's a whole team. To be honest with you, a lot of our team is ex-Motorola. Like, they used to do that kind of stuff, and they came over to the fun side, I guess, to the audio side. Yeah, it's a great team of digital experts. When we came into the digital age, from migrating from analog, yeah, they made it all happen. It's pretty fun. And we're doing really cool stuff now.
so Richard and then Manisha, and then I think we have to move on to the next speaker.
Sure.
So you do these all over the country. Obviously, the Super Bowls are played in different places.
Sure.
How does weather, temperature conditions, moisture, and all of those things affect these very low frequency microphones?
That's a great question. Yeah, I mean, most commonly, the adverse weather effects, I wouldn't say it affects, the propagation as much because they play in whatever weather, right? Maybe, yeah, some things you have to worry about propagation, but for more of the wireless portion, it's going to be like water in the capsule or like sweat out of the battery nest, making sure you waterproof the packs that the refs are wearing. Those are the type of things that are going to be more prone to failure rather than like, oh, we're not going to get the range we need because of particles in the air of moisture. That's usually the case in my experience.
Manisha?
Yeah, so I recently learned that the lower 3 gigahertz is also where there are a lot of SDAs for camera back radios. Do you also have audio microphones in that range?
We have friends that do 3 gigahertz and cameras in there. We don't have wireless microphones in there. And what it comes down to is wave propagation. characteristics and output power necessary, which also impacts battery life. So in order to get the range and the distances that we need, the 3 gig isn't that favorable. I need a lot more output power, meaning I need a bigger battery, a little shorter runtime. And a lot of these situations, I need to have good wave penetration through objects, which obviously 3 gig doesn't work as well as something in the 500 megahertz, right? So it's not something, I'm not saying we never would explore that, but for what people expect from a typical wireless microphone, yeah, the lower the frequency to an extent is better until you get into unmanageable antenna lengths and stuff. Yeah.
Well, thank you very much. We really appreciate.
Thanks for having me. I appreciate it. Thank you, guys.